Today's lesson is going to be about how to solve some AP Calculus free response questions. So today we have year 2010, number 4. Okay, so number 4, it gives us a graph with the shaded region, and number 4 says, let R be the region in the first quadrant bounded by the graph of y equals 2 rad x, the horizontal line y equals x, and the y-axis as shown in the figure above. Okay, so this is what we are given here, this information that's there. Okay, so in this question, it's asking us three things, part A, B, and C. Part A says, find the area of R. Okay, so R is this region here that it's shaded, and we want to find what the area is in this shaded region. Part B says, write but do not evaluate an integral expression that gives the volume of a solid generated when R is rotated around the horizontal line of y equals 7. Okay, so when we do that, that is all it's asking is we want to rotate this region around this imaginary y equals 7 right here, this line here. So we're just rotating it around and around. And then part C, region R, is the base of a solid for each y where 0 is less than or equal to y, which is less than and equal to 6. The cross-section of the solid taken perpendicular to the y-axis is a rectangle whose height is 3 times the length of its base in region R. Write but do not evaluate an integral expression that gives the volume of the solid. Okay, so what this is asking is it wants us to rotate along the this y-axis. It wants, okay, so along this axis here, it wants us, it's a whole bunch of rectangles, and it wants us to find the volume of those things. Okay, so this is a non-calculator question, so all the work that we're going to show is all going to have to be written out. Okay, so part A is asking us to find the area of this region R here. Okay, so normally when we would take the area, we would just multiply length times width. But because there's a curve here and it is not a square, we cannot do that. So what we do is we take the integral of the upper function minus the lower function. And our functions are this here, this curved line here. This is y equals 2 rad x, and then this line here is just y equals 6. So to find the area of this region R here that's shaded, we want to take the integral from 0 to 9 and then integrate the two functions, the upper function minus the lower function. Okay, so that looks like this. Okay, so the integral from 0 to 9, taking the upper function, which is 6, minus the lower function, which is 2 rad x, and then dx. Okay, so this is your integral here that you take to find the area of this region R here. So when we integrate this function here, so when we integrate that, we're going to get 6x minus 4/3 x to the 3/2, and then within our boundaries here, 0 and 9. Okay, so once we get this here, to find our area, we plug in these two values into this equation. So to do that, we basically take our f of b minus f of a formula, and that is our way to get to our area. So we plug in 9 into x, and then we plug 0 into x as well. So our b is 9. So to do that, we plug in 9, and we also plug in 0, which is a. So our f of b minus f of a is going to be 6 times 9 minus 4/3 times 9 to the 3/2, and then minus, because this is our f of b, and then we want to subtract our f of a. So our f of a would just be, then when we plug in 0, it'd just be 0 minus 0, because anything times 0 is just 0. So we're left with this. So to get our area, we just simplify all of this out. So we end up getting 54 minus 4/3 times 27. And then following that up, we get 54 minus 36. And we get an area of 18. So that is our answer to part A. Okay, so we have our answer for part A, but a common mistake people might make is that when they're taking the integral to find the area, they might mistake the upper and lower functions. Okay, so what that would look like is that people might, instead of taking your upper function minus your lower function, they would switch the two. So then they would accidentally write the integral from 0 to 9 of 2 rad x minus 6 dx. But that would be wrong, because if you were to do that, you would be finding the area of this region here below the equation of y, of this curved line of y equals 2 times rad x. So part B wants us to write an integral expression that gives us the volume of a solid generated when r is rotated around the horizontal line of y equals 7. So when the region r is rotated around the line of y equals 7, it's going to roughly look like this. So when we want to find the volume of when it's rotating around the line of y equals 7, what we have to do is we take the integral of the outer radius squared minus the inner radius squared. And the reason we have an inner radius is because the line of y equals 6 is not the line in which it is rotating around. So that's going to look like the integral from 0 to 9. And then we have our big radius, which is going to be 7 minus 2 rad x squared minus, and then our inner radius, which would be 7 minus 6 squared, and then dx. Okay, so now we have this, and all we have to do to get our final answer for what they're asking for is we get this integral from 0 to 9, 7 minus 2 rad x squared minus 1 squared. There'd be 1 squared, but 1 squared is just 1, so that's why we have that there. So then dx. And then because it's asking for the volume, and we're rotating around the line of y equals 7, it's gonna have a circular shape. So then we're gonna multiply it by pi. So then here is going to be your answer for part B. So now for part C. Okay, so in part C, because the base of the rectangular cross section is perpendicular to the y-axis, we have to change all the equations in terms of x. So when we do that, the equations are going to look like this. Okay, so x is now equal to y squared all over 4. Okay, so now with this here, to find the volume, we got to use the information that it's giving us. So now we have this here, so then this here, with the conditions that we're given, this is going to be our base. So then, because we want to find the area of each rectangle, it's going to be the base times the height, and the height is 3 times the base. So this is what we're going to use to get our area. So now that we have our length and height, we multiply them together, and we get an area of 3y to the 4th all over 16. So now that we have our area of each rectangle in the cross section, to find the volume, all you have to do is you take the integral, and you take the integral from the region in which it is bounded. So in this case, it's from 0 to 6, and then since you have that, now it's you just put dy at the end of it, and then this is your expression for part C. So that right there concludes the question number 4, a 2010 AP Calculus free response question. For more problems like these, you can go to your calculus book like this and turn to section or chapter 8 and go through all the sections. For example, part 8.2, and all throughout you have problems all like this.